So what is x equal to? So you should do 100 divided by 4.5 times 10 to the negative 6. Let me know what you get. So that's the answer. So it's 2, 2, comma, 2, 2, 2, comma, 2, 2, 2, and then dot 2, 2, right? Okay, yeah. So that's what I got. Now, what is this in terms of our units? So if you're using this formula, it should be in grams, right? Now, if I convert this to milliliters, this is a 1-to-1 ratio, right? 1 gram per, so this is the same thing as 2, 2, comma, 2, 2, 2, 2, 2, 2 liters. I'm going to just get rid of the decimal. Sorry, not liters, milliliters. And if I convert it into liters, I'll just have to, divide it by 1,000. So it'll be here. So this is wrong. So yeah, so there's a mistake here in the sense that because the units weren't given, you have to use it this way. You can't do it the other way. Yeah, not yet. If their units were grams over a gram or something like that, then you could possibly do it. But because they do milligrams over liters, just use the ratio that's given. Yeah. All right. So it was a good exercise. Yeah, good to know how to do this. Okay, so we're doing a dilution question now, right? Go ahead and read first. Okay. So, so you got initial volume is 500 mils, right? Concentrated acetic acid, and is diluted to make a 5% solution. Find the volume of the dilute solution that is prepared. Wait, do you have a equation for this? Sorry, I'm going to repeat that. So I'm going to assume that the initial concentration is 100% because concentrated acetic acid is pure. So if it's 100%, remember when you're dealing with percents, you don't actually keep it in percent. You kind of just write it as a decimal. So 100% is the same thing as 1. And we know initial volume is 500 mils, right? And our formula is C1V1 equals C2V2. So now our second concentration is 5%. So we're going to do 0.05. And find the volume of the dilute solution that is prepared. This is unknown. This is X. So see if we can solve for X now. See if that works. So divided by 1,000 if you want to convert it into liters. And then what do you get? 10 liters. So now is it right? Perfect. There you go. So wasn't that hard. Okay, question number 4. Go ahead and read, please. Okay, so when it comes to dilutions, what's the equation again? So go ahead and see if you can solve this. So yeah, so the tricky part is just figuring out what goes where. So you tell me, what do you think? Where do you think like these numbers go? There's 3 numbers given. So where does the 25 go? What do you think? Okay, so you think 25 goes to C1? Keep going. What else? Okay, which one? Okay, so you think 500 goes to V1, keep going. And then what's the last number? 108. Yeah, where does that go? C1 again? Oh, C2. Okay, got it. Okay, my question is, are you randomly guessing? Got it. All right. So let's narrow down some stuff. First things first. Look at the units. That should help you. What's the unit here? Okay, is that a unit of concentration or is that a unit of volume? Volume. So this can never be C. I'll give you that hint right now. So 25 mils has to be volume. So now you have two options. It can either be V1 or V2. So let's read the situation. What's happening? Is 25 mils the initial, like beginning amount, or is it the final amount? Like, did you start with 25 mils and then get 500 mils, or did you start with 500 mils and then go to 25 mils? What happened? So you got to read. A 25 mil sample was diluted to 500 mils. Exactly right. 25 was the initial. So V1 has to be 25. That means 500, once again, it's mils, has to be what? V2. So there you go. We figured out most of it. Now the only thing left is C1 and C2. What is the question asking to solve for? Is the question asking to solve for C1 or C2? Yeah. What was the molar concentration of the original sample? So what do you think? Do you think that's C1 or C2? The battery is low. Yeah, so the original sample is C1. So this is what our unknown is. That means C2 has to be what? 0.108. Exactly right. Now plug in these values and solve for C1. That's it. Let me know what you get. 2.16. Now what's the unit? So the units are moles per liter. Does that make sense? Yeah, and it's also concentration, so it has to be something like moles per liter. So, okay, so we can check if we did it right. So this is a solubility question. You're going to be given so most solubility questions are double distillation reactions where you have double distillation. So two compounds adding together, and then you have two compounds for your products and reactants, and you have to figure out whether there's a reaction or not. So go ahead and see if you can do it for these first two things. So potassium carbonate. Do you know what the chemical formula for that is? Yeah, very close. KCO3. The only thing is, do you know what the charge for CO3 is and the charge for K is? Yeah, that makes a little bit more sense to me. And then copper 2 sulfate, what would that be? Sulfate's SO4 2 minus. Yeah, and any numbers and a 2 here. Nope. Nope. Because what's the charge on copper? It's in the name. Yeah, so charge of copper is +2, charge of sulfate is -2. Because they're the same, they kind of like cancel out. You don't have to write it exactly. All right, and now what are the products? Close. K2SO4. Because remember, potassium is +1, and then you crisscross. And then what about the last one? And since they're both charges of +2 and -2, then yeah, you don't write anything. So now you need to figure out, if you read the question, which of the following pairs of aqueous solutions produce a precipitate when mixed together? So they're telling you that initially both of these are aqueous, because they're saying aqueous solutions. And now you need to look at your solubility chart to compare these two compounds and see which one of these, if any, are solid. So go ahead and look at your solubility chart and see if you can figure this out. Okay, so this is the solubility chart. Did you find potassium carbonate anywhere? So potassium is here, carbonate is here, and if you that's soluble, yeah. So that means it's aqueous, right? Okay. And what was the other thing? So copper sulfate. So copper is here, sulfate is here. Let's check. What's that going to be? Soluble. So in this example, oh, where did it go? Here it is. Both of these are aqueous. And when that occurs, something important that you need to understand is happening. NR. That means there's actually no reaction occurring here. They're all aqueous, exactly. Let's try B now. So the exact same thing for B. So go ahead and see if you can write aluminum chloride. So what's the formula for aluminum chloride? Sorry, ammonium chloride. I apologize. Is it? I thought ammonium was NH4. Yes, ammonia NH3, ammonium NH4 plus. So go ahead and write ammonium chloride. What would that look like? Perfect. And zinc sulfate. Yeah, ZnSO4. What about any numbers? Subscripts? Perfect. They both have a charge of 2, yeah. +2 and -2. All right, so we're good with these two. And when the question tells us that the initial things are all aqueous solutions. So what about the products? What's the formula for the product? Close. NH4SO4. What about the numbers? Yes. So now we just got to figure out whether it's soluble or not. So let's go back to our solubility chart. So ammonium sulfate and zinc chloride. Ammonium sulfate and zinc chloride. Let's look for ammonium first, shall we? So ammonium sulfate, so that's aqueous, and then zinc chloride. Where's zinc? Zinc is here, and chlorine is here. So it's aqueous. Okay, so in this example, both were no reactions.